Hi guys, welcome to Learn Electronics Repair. This is not a product review video, I will just mention straight away. This is not a sponsored video. I bought this myself out of my own pocket at the car boot sale on Sunday, a couple of days ago. The guy had about a dozen of these. I actually saw them a couple of weeks ago. He had a big pile of them, I didn't bother. And then this weekend he had about 3 of them left. Yeah, so I thought, you know what? Let's buy one of these, which is the cheapest multimeter I can find. So I paid €3 for this. You can see it's brand new. I've had a look on AliExpress. They do sell these. With the postage, you pay more like €4 or €5. You can see the model DT-830B. So this is the cheapest multimeter I can find. I already have, let me see, 1, 2, 3, 5 other multimeters anyway, so I don't need this, but I thought you guys might be interested, and actually I'm interested as well, not just you guys. I'm interested to see how useful this actually is for repair work. Yeah, I mean, some of you guys I know are short of money, and it would be nice to see if we can actually use this. Is it useful? Can we fix stuff with it? Yeah. So let's have a look. It has specifications on the back, so I think you can see it clearly. Resolution of DC voltage down to 100 microvolts, that's pretty good. AC voltage also down to 100 microvolts. It'll go up to 1000 volts DC, 750 AC. It has resolution on DC amps down to 100 nanoamps. Okay, that's like 1/10 of a microamp. Resistance down to 0.1 of an ohm. Current up to 10 amps, I just didn't mention. And it seems like the highest resistance is 2 meg. Okay, 2000k 2 meg. It has diode test mode with a test current of 1.5 milliamps. It has gain measurements, NPN and PNP, 0 to 1000. Okay, it's telling us it uses 2.8 volts collector emitter, 10 microamp current for the base. Okay, and temperature, -40 to around 1000, it says. Yeah. It has a buzzer, a built-in buzzer, sounds if the resistance is less than 30. Plus or minus 20 ohms. Okay, so it has all that. It has some instructions with it. That seems like a rather lot to me for €3. Let's have a look. Okay, I guess there's no batteries with it, but we can sort that out. These are the little test leads. They're not very long, I will say. Let me just compare them to my normal test leads. Okay, this is a test lead. Yeah, that kind of ends there. It's hard to get into the shot like this, guys. I have to zoom out to do it. Okay, so yeah, test leads. That ends there, okay. This one is like, I think it's actually, yeah, as near as damn it twice as long as the normal one. But, you know, you could find some test leads for this. Probably cost you more than the meter, but you can buy some, yeah. Oh. It has batteries in it, wow. Not only was it €3, but it also comes with batteries in it. Amazing, yeah. So let's have a look. They fit in. Okay, I mean, when they fit in, like the little plasticky thing goes in the slot, so you can't poke your fingers on it. Let's zoom back down again. Okay, well, I think the first thing we should test with this is continuity range. If I get a new multimeter, the first thing I want to know is how fast is the bleeper, yeah? I mean, it's manual ranging, you know, you have to change the range, but let's see. Well, it doesn't bleep. Yeah, it sort of gets close to 0. Yeah, it goes down to 0 pretty close. Doesn't bleep. That's interesting. You bleep on diode mode. No, it doesn't bleep, but it says it bleeps. Let me look at those instructions again, yeah? Buzzer. Built-in buzzer sounds if resistance is less than 30 plus or minus 20, which is somewhere between 10 and 50, I guess. Okay. Oh. Am I misunderstanding this? Do I have to select something to make it bleep? No. 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 200 ohms. Okay. Doesn't zero particularly well, but it works. Diode test. And it doesn't bleep. That's strange. I don't quite understand that. I wonder if this is faulty. Bleeper doesn't seem to work. That's the first thing we can say. Let's try it diode and diode mode. Okay. It works. Yeah, it works. So the only thing I'm a bit surprised so far is the bleeper doesn't work. I wonder if the batteries are a bit flat. Is that for plus and minus here? It doesn't really say. I'm not sure whether that's saying it's like a low battery symbol. Maybe that's why it's not bleeping. Let's have a look. Let's see what's inside this anyway. Okay, I think this will just come off, yeah. So it actually has a 9-volt battery in it. Let's measure it. Let's just see if that battery's any good. Okay. Yeah, the battery's low. Maybe that's why it isn't bleeping. Let me see if I can find another one. Okay, so I have a battery. Just check, this is a good one. Oh yeah, 9.78 volts, that's plenty, yeah. Let's put this one in and see if it works better. Well, it was working well, it wasn't bleeping. So, just while we're in here, you can see the little PCB. This bit seems to be like soldered on afterwards, the one where you put the sockets. Oh, this must be the current shunt, this thing here on the 10 amp range, so it obviously measures the voltage across that, which will have some resistance, so that's how the 10 amp range works. Put it together. Oh, is it interesting? Can you read this, guys? So, this instrument contains no operator serviceable parts. Screw removal by qualified persons only. So, whoever made this is saying that I can't change the battery. There's an email address for this company. Who made this thing? So, I'll have to see if I can find who makes this and email them and ask them why I'm not permitted to change the battery. Because that's what it's saying. You can't change the battery, which seems like silly. Warning, to avoid shock, remove inputs before opening. Okay, fair enough. Close cover before using. Fuse 0.5 amp. 250 volts. How does that work? On the 10 amp range. Oh, I assume that the 10 amps only goes through the shunt and doesn't actually go through the fuse. So, where's the fuse? Oh, this doesn't want to. Oh, it will come out if you undo the 2 screws. Let's have a look. Let's have a look. Where's the fuse? I assume the fuse is not used as serviceable either. And yet I would think that by definition a battery or a fuse is like supposedly used as serviceable. Okay. It's come apart without damaging it. It does if you undo the other screw, I think. Still something holding it in place. I don't want to break it because I want to test it, yeah. I don't want to damage it, I want to actually test it. So there's like a little clip by the way. Let's have a look. Push that back. Does it come out now? I think I might have broken the clip. This is glued in or something, guys. So, where's my torch? Oh, the torch is in the van. Well, I don't see any components on the other side of this board at all. Just like the switch on the contacts. We might have to break it later, guys, because I want to see where this fuse is, yeah. But right for now, I actually want to try it. But that switch covers like the whole back of this PCB. And I'm looking like, yeah, it looks like that's how it also connects to the display, effectively. I can't, at the moment, see a fuse. Could be an SMD fuse, of course. Maybe I'm looking in the wrong place there, guys. Maybe it's an SMD fuse. Wish I had to try to take this apart. Well, we have our new battery fitted, so let's try it. Yeah, let's try it. I'm going to keep positive and open-minded about this. Yeah, I'm not going to be prejudiced in any way, even though I couldn't see where the fuse is. Okay. And even though I'm not obviously qualified to change the battery, it's just told me, yeah. I mean, they don't even know me, yeah? And they know enough to tell me that I can't change the battery. Okay. Try, so. We'll get over that one, yeah? Diode range again, let's try it. These things are a bit shite, these Teslas, but okay, we can get around that. Well, it measures it, yeah, it measures the voltage drop. Well, compare it with the Fluke and the Maze or something else. Low ohms range. It doesn't bleep. Why doesn't it bleep? Why doesn't it bleep? I mean, what am I doing wrong here? Yeah. What am I doing wrong? I have to come back to that because I don't understand that. Why I can't get it to bleep. Okay. One Fluke meter. We'll go to ohms. We'll go to diode range first. I have a diode here. Okay. Diode range. Okay. Let's measure a couple of 3 diodes. So, one diode. 508. .535, which is right, do you think? Let's try the Kyrwitz. Okay. Diode mode. Is it 508? Is it 535? Yeah, let's have a look. Oh, would you believe it? This is the closest to this one. 536. 531. I think we need like a best out of 4 or something. Let's try the Aneng. Yeah, let's try the Aneng. Diode mode. Yeah, I'm on the right lead, yeah. Am I on the right leads? I am on the right leads. 543. Okay, so they all read different in actual fact. But the fluke is the only one that bleeps. Yeah, on the diode. That's the only one. Let's try this again. No, that one bleeps as well. Doesn't bleep on the diode. And while we're at it, let's get the last one. This was a Christmas gift, by the way. Diode mode. I don't have to press the function button to get to diode mode. That's ohms. That's diode, okay? Doesn't bleep when you short them. Try a diode. 537. So interestingly enough, the only one that reads really different from all the other ones is the fluke. And I'd have to assume the fluke is not reading correctly. Okay. Let's measure some resistors then. So we have a 22 ohm resistor. So 22 ohms exactly. This one 22. On the diode range, let me actually go to the ohms range. 22. Okay. What else do we have? This is a very low value resistor, so 0.22. Is about 0.8. On the fluke, 0.1. And I'll measure that on the aneng because the aneng gives me a extra decimal point basically. Let's go on to the aneng. Ohms range. Yeah. Not quite zeroing. 0.404. 0.08, so that's reading about 0.3, okay. Possibly you can zero this one. I'd have to have a look to see if it has a zero option. Okay. So the measuring, what else do we have? This one's quite a high value one. I think this is a 1 meg. Yeah, 0.995. What's this thing of it? Actually, I put the range. Remember, this is manual ranging. 0.985. Okay. And this one is somewhere in between. This is a 22k or something like that. Let's go to the 200k range. Yeah, 21.2, 21.5. Okay, so it measures stuff, or gives you a reasonable approximation of it at least. Let's just try it on voltage and current, and we'll try the transistor tester as well. Yeah, let's try the transistor tester first. None of my other multimeters actually have a transistor tester, but we can try on this. So this is a NPN transistor. We need to know what the transistor is before we can test it, unlike a component analyzer. And I think it goes this way: emitter base collector. No, it's emitter collector base. It goes this way: emitter base collector. Let's have a look. Yeah. Gain was 280 something. Okay, we can compare that with a component analyzer. Let's have a look at this one. So this is a 327 BC327. This is a PMP version of that I just tried, basically the complementary one. So again, we have emitter is this end. Which goes in there. Bit of a dodgy contact on it, but I believe we got 219. 260. Okay, so let's look what they measure on my peak analyzer with a rather flat battery, but we'll try it. $250. That was about similar. This one I think went a bit higher. Yeah, I'd say it does that. It certainly tells us it's a good transistor or not. Can't complain at that. That works. Let's try measuring some DC voltage. I'm just going to use my bench power supply. I'll get a camera where you can see it. Okay, you can see it there. So we'll just head for something like 12 volts. Okay. Let's see what we get. So I'll just connect the meter. I'm on the DC voltage range, 20 volt range. And it's reading. Yeah, let's compare that with the fluke. I'm not sure how accurate that is anyway. Yeah, 1207, a bit closer if that is accurate. Let's just measure some low voltages. Turn this down. 1 volt. 1 volt on there. Let's have a look. So that's reading 106. 105. And then we'll just go up to the full 30 volt or a bit more. 31.5. Okay, this is over range, it's manual ranging, which is reading 32 volts now. 31.5 volts. It gives a pretty reasonable representation. I mean, repair work normally wants to know is the voltage there or isn't it there? Yeah, and is it roughly what you want it to be or what you'd expect it to be? So current. Well, this is a very sensitive amp range, and that's similar, if you like, to my little Aneng meter. So to test this, I'm going to just use it in the way I most commonly do for low current, which is to measure the current draw on the CMOS battery on a motherboard. It gives a very good idea of the state of the SIO chip and the south bridge. Let's try one. Okay, here's one of my test motherboards. So the way I would test the current draw, first of all we go onto the low range, 200 microamps, okay, 200 microamp range. Let's do it. So basically we put the red lead onto the battery and we push the little clip back with the black one, yeah? And we can see there that that is drawing 1.6 microamps, okay? Let's compare that with the little Aneng. It's the one I normally use for current measurement because it has the more sensitive range than the fluke, okay? So we can go to microamps. Okay, so this is on the microamps range. It reads it to 0.01 microamp. So that one was giving 1.6. What's this one actually giving us? 1.61. So that's very accurate. Yeah, that was very accurate on microamps compared to this one, if this one's correct. How about some higher current? So we'll try the 200 milliamp range. I think I'll measure this by just looking to see what current's coming out of one of my other meters effectively. So yeah, this is my low ohms, my milliohm meter. So on this range it should give 50 milliamps and this will be 100 milliamps, okay? That's the test current. So let's have a look. We'll try on this first. Okay, so we go to milliamps range. I'm just going to effectively connect the two to each other. So let's see what current goes into the meter. Yeah, so is it going to be 50? No. Well, you know why? Because I have that in the wrong place. Put it in there. Let's try it again. Yeah, 51 milliamps. Okay. What's this other little meter think of it? Okay. 52 milliamps. Fine. And then on the higher range, there should be 100 milliamps. Okay. 101. 103. So it reads roughly what you would expect. Roughly. Just want to try now the 10 amp range. This could be fun. So I'm not going to try the high voltage testing on this, by the way. I don't like to look at these probes very much. I'm sure you could do it. I'm sure it would read a few hundred volts, but I don't feel inclined to. Tell me in the comments below, call me chicken, whatever. Yeah, current. So we're at 1 amp. We're set to 1 amp, yeah. Let's try and measure that through the meter. Okay, so 10 amp range. Let's use the cheaper one. Yeah, let's use the cheaper one. Okay. So this should send 1 amp into this meter. And it does. Yeah, it does. It does. What happens if we turn the current up? Two amps. 3 amps. So we stick 10 amps into it. Well, 8.6 due to the resistance of the leads. I mean, it's fairly common for meters not to be able to take a high current for a long time. Doesn't feel hot or anything. Okay, let's try that on our other meter. Okay, so we'll use this one. This has a 10 amps range, so common amps. Switch it on. It's gone to the amps range by itself. Let's see what this does. Put some current into it. Okay, yeah, we have current. Move that way, can you see it? Sorry guys, it would move slightly. That's reading quite accurately. Stick some more current into it. And this tops out at the same, so basically that is the resistance of the leads, preventing it going to 10 amps. So I think on amps range that little meter works just fine, yeah. Okay, so far so mediocre, yeah. I mean, it basically works. All the functions seem to work, apart from the one we really need, and that's the bleeper on continuity. And I can't get it to bleep. I mean, there's no other buttons. So let's see if we can fix it. Let's see if we can figure out what's wrong with this. Yeah, why doesn't it bleep? And while we're at it, where's the fuse? Okay, we're back inside again. Because if you do any repair work, you will know that without a continuity bleeper for repair work, this is basically useless. You might just keep it as a spare meter if you want to read current and voltage at the same time or something. Just have this reading the current maybe, or the voltage. As long as you're not too fussed about exactly what it is, just like, is it roughly what it should be? Which, to be honest, with repair work is quite common. So as we get into this thing now, I'll just zoom down a bit. The first one then is, where is the fuse? These two pads here are supposed to have a fuse on them. Are they connected to each other, like shorted? Let's have a look. These two pads connect together. They do connect together. I wonder if, like, that is supposed to be the fuse, but it's like omitted on this model. Like somebody didn't put one in. How do we get this out of here? I wouldn't be surprised that's the fuse, by the way, guys. But maybe the fuse is optional, like, and they're just telling you what fuse you should put in yourself. Yeah, maybe that's what it means. Seems to be some... You know, I don't know if these effectively like are just solder bridges, and if we unsolder, we can take this board out, and this one stays in. Yeah, what do you think? Let's have a look. I think I've solved the mystery of the fuse. It's there. I think that's where it is. Maybe it's on the other side. Maybe I'm actually reading the fuse. Okay, let's see if these are actually what holds it together effectively. Looks that way. Yeah. Okay. That was a good guess, weren't it, guys? That was a good guess. So this will come out now. Right, well, there's no fuse. I mean, we know where the fuse was, and there's no fuse. And where's the bleeper? Guys, where's the bleeper? Yeah, where's the component that makes the noise? I mean, this is a display. That's the connection effectively to the display from the board, which just pushes on all these little contacts here. That's fair enough. Where's the bleeper? I think somebody forgot to install it. I think somebody, somewhere, has forgot to connect the bleeper. I wonder where he's supposed to go. If I knew what this was, I could probably figure it out. I mean, maybe we could figure it out if we, like, yeah. We'd have to get into continuity mode. Put us back in here and put it, easiest way to put it back together. And then short the leads and put our scope around here, see if we can see like a square wave audio type thing coming out of it. Yeah, let's try that. If we can get it back together. Just realised I should have undone this screw, by the way, which I didn't. Yeah. Right. Let's see if we can sort it. Well, I'm going to throw caution to the wind now, because I'm actually operating it without the back on, yeah, which they told me not to do. And it's working. I'm in continuity mode, but it's not bleeping. Now, if I can trust the manual, the instruction book, that should bleep, yeah, if it's less than like 50 ohms or 30 ohms. But like, I'm not sure I can believe the manual, because the manual also told me it had a fuse and there isn't one. Unless that's like the deluxe version. Maybe I've got the manual to the deluxe version and like a different model. Let me see. 830B. 830B. No, I have what it says on the box. Well, I have some of it. I don't have the fuse. And I'm not so sure about the bleeper. Okay, so I'm going to short these two together with a crocodile clip lead, and I'm going to have a probe around on these to see if I can see a square wave like audio type signal somewhere. Okay, so there's a crocodile clip lead. It's now reading less than 1 ohm. Let me find the little handheld scope. It's the easiest one to use. Actually, when I say easiest one to use, I mean the easiest one to use on camera, yeah, basically. Right, now let's get a ground on here. And let's see if we can see anything oscillating. So, meters on continuity. The leads are shorted. What we got? Well, that looks like a square wave. Frequency is that thing? Well, it's like 5 milliseconds, yeah. Not sure what the frequency actually is. Oh, it's 50 hertz. That's a 50 hertz. So that ain't it. That's a 50 hertz. What's the 50 hertz signals on this? Seems to be everywhere. What the hell? Why would all these pins have 50 signals on them? Strange, but true. All I can see is 50 Hz signals. Not here. Just on those top ones. It's gone bleep. No, it's still measuring. It's my soldering iron that went bleep. That's pulsing. It's a very low frequency. That one is. That one is. Okay. Well, that ain't a bleeper. Oops. Still working. Put this back on again. Okay. So look on these sides. 50 Hz. 50 Hz. All these 50 Hz. Oh, what's that? Let me just remove the short. No, that keeps going even when there isn't a short on there. That's not it. That's not the bleep. Thought I had it then, guys, but that signal's there always. Another one. Does that stop when we remove the short? Nope. So that's not it. Earth lead falling off several times. Another one. Still there. And we'll just go, well, that's it. We've been all around it, guys. So wherever the bleeper signal is, if there is one, it ain't coming out of that. And there's nothing much else you can really look around on here, you know. Low frequency. That's where we were looking. Guys, I have to say this one's beyond me. Yeah. It says it bleeps. I can't find a bleeper and I can't find a signal which would connect to the bleeper. So, verdict. Is this €3 meter any good for fault finding? Well, you can measure voltage and resistance with it. You can test diodes, you can test transistors with it, you can measure current with it, low current at the microamps, high current at 10 amps, and it'll do all that. And although it may not be the most accurate thing in the world, it's probably a good enough indicator. But when it comes to fault finding, it doesn't have a bleeper. Yeah, no bleeping bleeper. Even though the manual says it has a bleeper, yeah, it has no buzzer, no bleeping bleeper. It's useless, guys. It's useless for fault finding. And that's such a shame, because if only the bleeper bleeped, it'd be pretty bleeping good, yeah, for €3. So, yeah, bin. But I'm keeping the battery, that was mine, yeah. Okay, hope you enjoyed that, guys. Comments below, do you agree, do you disagree? Yeah, I have another meter coming from a company sell on AliExpress, which is about €10 or thereabouts, and that one is a review. They've asked me to look at it to see if it's worth using for fault finding, so we'll wait until that one. This, nah. Okay, see you all soon, guys.